Hello everyone, in this video we are going to write down all the acyclic isomers of C6H12. This elemental composition would fit into the molecular formula CnH2n with the n value equal to 6. The degree of unsaturation for this elemental composition is 1, which we can prove it 1 plus number of carbon atoms minus number of hydrogen atoms by 2, therefore 1 plus 6 minus 12 by 2, therefore 7 minus 6, and that is equal to 1. So this means that both alkenes are possible as well as cycloalkanes are possible, but we are not going to write down cycloalkanes right now. We are just going to write down all the isomers that contain a carbon-carbon double bond. I am going to write all the isomers in bond line notation just to save time. Number 1, we can write hex 1 in 1, 2, 3, 4, 5, 6 and then 1 double bond. Let's number it. This is hex 1 in, and then number 2 we can also write hex 2 in. But now cis-trans isomerism is possible, but I am going to follow EZ convention so that it would be less confusing. So let us write the E isomer. In the case of E, the higher priorities should be on the opposite side. So 1, 2, 3 and then 4 and then 5 and then 6. As per the Kohn-Ingold-Prelog rules, carbon would get the high priority and we do have a hydrogen here that would get the least priority. Here also we have a hydrogen that we are not showing it in bond line notation. So that would get the least priority and carbon would get the top priority because atomic number of carbon is higher than the atomic number of hydrogen. So since the priorities are on the opposite side, this should be called E isomer. Therefore, this is 2E hex 2E. By the way, this 2E in parenthesis specifies the geometrical isomerism, whereas this 2 specifies the position of the double bond. Therefore, we have to mention 2 times. Let's write the Z isomer also. That is number 3, 1, 2, 3 and then 4 and then 5 and then 6. Here the priorities are on the same side. Both the hydrogens are down. Since the priorities are on the same side, this is called Z isomer. So 2Z hex 2E. And then number 4, we can also write hex 3 in. That would once again will have E and Z isomers. So number 4, 1, 2, 3 and then carbon-carbon double bond 4 and then 5, 6. We are writing the E isomer. So this is 1, 2, 3, 4, 5, 6. Higher priorities are on the opposite side. 1 here, 2 here, 2 here and then 1 here. Therefore, this is 3E hex 3 in. And then number 5, the Z isomer of this, that is 1, 2, 3, 4 and then the carbon-carbon double bond between 3 and 4 and then 5 and then 6. So this one is 3Z hex 3 in. We are exhausted with the hexene chain because we can't put the double bond here. Then if you number it from right hand side, it would become hex 2 in. If you number it from here, it would appear like hex 4 in. But this is a redundancy. Therefore, we should not write this. And then number 6, let's go to the pentene chain. Let us first write pent 1 in 1, 2, 3, 4, 5 and then put a methyl group at second position. No cis-trans isomerism is possible because here we have 2 hydrogens. So this is 2-methyl pent 1 in. And then number 7, we can write 3-methyl pent 1 in. That is 1, 2, 3, 4, 5. At 3 position, 1 methyl group and then at 1 position, the carbon-carbon double bond. This molecule is chiral. Therefore, we can write 2 isomers. Both R and S is possible, isn't it? So that is 7 and then the 8th one is this one. It's an enantiomer. Here if we are assigning priorities, then the hidden hydrogen that is here would get the least priority, that is 4, and then we have a carbon here, carbon here, carbon here, but this carbon is connected to a double bond, therefore that would get the top priority because this should be counted as like carbon connected to carbon and then one hydrogen, whereas for this methyl group it is simply hydrogen, hydrogen, hydrogen. For this carbon it is connected to this carbon, therefore that is carbon and then 2 hydrogens. So therefore this is number 1 priority, this is third priority, and this will be second priority. So if we are looking from this side, and if you get into feature projection, then hydrogen atom is on the right hand side, methyl group that is the third priority is on the left hand side, and then 2 is at the top, 1 is bottom, but we need to bring the 4 down so that we can assign the priority. Therefore we need to do one swap. So if we do a swap between 4 and 1, then 1 here, 2 at the top still, and 3 on the left hand side. This is counterclockwise, that means yes, but we did one swap between 4 and 1, and therefore the original is R, therefore the absolute configuration at this place is R. This means that for the other one it is S. Therefore the correct IUPAC name for molecule 7 is in parenthesis 3R and then 3 methyl pent 1ene. Likewise for the enantiomer, the correct IUPAC name is 3S 3 methyl pent 1ene. And then number 9, we can also write 4 methyl pent 1ene, that is another isomer. 1 2 3 4 5, double bond at 1 position, and then 1 methyl group at 4th position. So this is 4 methyl pent 1ene. No cis trans isomerism is possible because on one end of the double bond we have 2 hydrogens. And then number 10, we are exhausted with the pent 1ene option. Let's go to pent 2ene option. 1 2 3 4 5, double bond between 2 and 3, and then 1 methyl group at position 2. Here also no cis trans isomerism is possible because on one end of the double bond we have 2 methyl groups. So therefore the IUPAC name for this molecule is 2 methyl pent 2ene. And then number 11, we can write 3 methyl pent 2ene, but there we are going to have geometrical isomerism once again. So 1 2 3, and then 1 methyl group at 3 position, and then 4 and then 5, and then the double bond between 2 and 3. So this is 2E, same like the way we assign the Korn-Ingold-Prelog rules. Higher priorities are on the opposite side, isn't it? This is higher priority, here this is low priority, this is low priority, and this is higher priority. Higher priorities are on the opposite side, and therefore this is E isomer. Therefore the IUPAC name for this molecule is 2E and then 3 methyl pent 2E, and then the Z isomer, that is 1 2 3, and then the methyl group down, and then 4 and then 5. Now the higher priorities are on the same side, therefore this is 2Z 3 methyl pent 2ene. And then number 14, we can also write 4 methyl pent 2ene, that is once again is going to have En Z isomers. So 1 2 3, and then 4 and then 5, and then 1 methyl group, carbon carbon double bond between 2 and 3. So here the top priority, here the second priority, here the second priority, here the top priority. Higher priorities are on the opposite side, therefore this is E isomer. Therefore this is 2E 4 methyl pent 2ene, and then the Z isomer, that is 1 2 3, and then the carbon carbon double bond, and then 4 and then 5, and then 1 methyl group at 4th position. Top priority, second priority, second priority, top priority. Higher priorities are on the same side. So this is 2Z 4 methyl pent 2ene. And then number 15, We are exhausted with the pentene chain. Let's go to butene chain. 1, 2, 3, 4, and then put a double bond between 1 and 2, and then 2 methyl groups, 1 at 2 position, 1 at 3 position. So this is 2, 3 dimethyl but 1ene. And then number 16, let's move both the methyl groups at third position. That is another isomer. 1, 2, 3, 4, 2 methyl groups at position 3, carbon-carbon double bond between 1 and 2. This is 3, 3 dimethyl but 1ene. And then number 17, we are going to write but 2ene with the 2 methyl groups. 1, 2, 3, 4, 1 methyl group at second position, 1 methyl group at third position. 1, 2, 3, 4. So this is 2, 3 dimethyl but 2ene. And then one more isomer, that is number 18. We are going to write 3-methylidene pentane. That is 1, 2, 3, 4, 5, and then a CH2 unit with a double bond at third position. Let's number it 1, 2, 3, 4, 5. This is 3-methylidene pentane. In the earlier literature, you might see the same molecule with the name 3-methylene pentane, but it is better to use the name methylidene to avoid confusion of the following. So when we say methylidene, what we mean is double bond and then CH2. That is what we mean by methylidene. But when we say methylene, it is single bond CH2 and then again single bond. But in the earlier literature, these two were interchangeably used. Whether we attach CH2 with a double bond or CH2 with 2 single bonds, methylene was used, but that is corrected now. So the preferred IUPAC name is 3-methylidene pentane. You might also see names like 2-ethyl but 1ene for this molecule, but that is not the preferred IUPAC name. So in total, we have written 18 acyclic isomers of C6H12 and their correct IUPAC names.